The 10,000 TPS threshold. Ethereum nodes spend 90% of their time sitting idle while waiting for the network to reach consensus. This latency is the structural ceiling that has kept decentralized finance trapped in a low-frequency environment for a decade. But as of May 2026, Monad is consistently hitting 10,000 transactions per second on its Phase 3 testnet. This is not a theoretical benchmark or a marketing projection. It is the result of a fundamental architectural divorce between how a network agrees on the order of transactions and when it actually executes them. By breaking the lockstep between consensus and computation, Monad is finally delivering the performance of a high-frequency trading desk within a standard Ethereum virtual machine environment. The sequential execution trap. Traditional blockchains suffer from a chronic coupling problem. In a standard EVM setup, a node must agree on a block and execute every transaction within that block before it can even start thinking about the next one. This creates a stop-and-start rhythm that wastes massive amounts of hardware potential. It is the equivalent of a restaurant where the chef refuses to start a new order until the previous customer has finished their dessert and paid the bill. This sequential bottleneck is why your gas fees spike the moment a popular NFT drop or a volatile market event occurs. While the industry spent years trying to fix this with Layer 2 rollups and sidechains, these solutions often just fragmented liquidity and added complexity without solving the core compute inefficiency. Monad targets the source of the rot by rethinking the very sequence of the blockchain heartbeat. This leads us directly to the concept of separating the agreement from the action. The deferred execution breakthrough. Monad's Phase 3 breakthrough is a mechanism called deferred execution. Instead of forcing every node to compute the results of a transaction before reaching consensus, the network focuses purely on the official ordering. Think of it as a busy stock exchange, where the clerks record the sequence of trades instantly, but leave the actual clearing and settlement to a separate, high-speed back office. By the time a node is executing block 100, it is already reaching consensus on block 110. This pipelining allows the execution engine to run at full throttle without being throttled by the slower speed of network gossip. In this May 2026 testnet phase, we are seeing this separation allow for sub-second finality even under heavy loads of tokenized Nasdaq equity trades. The critical nuance is that the order remains deterministic, which is the only reason the math still checks out. Maintaining the EVM standard, speed usually comes at the cost of compatibility. Chains like Solana achieved massive throughput by abandoning the EVM entirely, forcing developers to learn new languages and rebuild their entire stack. Monad took the harder path of staying 100% bytecode compatible. This means every battle-tested Solidity contract and every existing developer tool works out of the box. However, the engineering team had to build a custom state database called MonadDB to handle the massive I/O demands of parallel execution. Traditional databases are too slow to keep up with 10,000 transactions per second, so Monad treats the disk as a specialized high-speed cache. This allows for asynchronous state access, meaning a transaction waiting for data from the disk doesn't block other transactions from moving forward. It is the first time we have seen high-frequency trading architecture successfully ported into the decentralized world without breaking the standards that define the industry. This technical maturity is why we are now seeing massive institutional players migrating their on-chain credit products from legacy L2s to this native L1 environment. The signal under the noise. The true implication of Monad's Phase 3 success is the complete invalidation of the narrative that the EVM is a legacy bottleneck. By proving that deferred execution and parallel I/O can scale an L1 to 10,000 TPS, Monad has effectively turned the Layer 2 scaling roadmap into a choice rather than a necessity. We are seeing a massive shift in how capital flows as institutional liquidity for tokenized treasuries, and Bitcoin-backed assets like CBBTC moves toward this high-throughput L1 instead of fragmented rollups. For developers, this means the end of the gas optimization era, where complex logic had to be stripped away to save on compute costs. For investors, the signal is clear. The market is beginning to value execution efficiency over theoretical modularity. The rivalry with Mega ETH and other real-time execution layers will define the rest of 2026, but Monad's first-mover advantage in the parallel L1 space is currently reflected in its steady valuation floor compared to more volatile competitors. Watch the mainnet transition audit results scheduled for late June. If the deferred execution safety checks pass without a hitch, the era of the slow EVM is officially over. Subscribe for more.